So Mr. Kailas Jagtap, he is the CAE engineer by profession with 4 years of experience working in ANSYS CFD. He has done his CAD CAM and robotics from KJ Somaya College of Engineering, Mumbai. He has done his bachelor's in mechanical engineering from Gokhale Education Society's Arhat Sapat College of Engineering, Nashik. He has experience as an ANSYS certified professional, CFD. He has guided for the projects in the field of CAE and given project support for various MTech and PhD research scholars. He has also been the judge for SAE Baja Competition 2021. He has worked in IISc Bangalore as a researcher. He has also published papers at national and international level conferences and journals. He has done pre-sales and post-sales activities, webinars, guest lectures, project consultation. Currently working as an application engineer at ANSYS Academy in ARK Info Solutions Private Limited since August 2018. During this tenure, he has given number of training and webinars in ANSYS Mechanical CFD in many institutes, universities, training centers, industries in India and SAARC countries. So, a very warm welcome, sir. We are indeed very fortunate that you are going to have this session to the participants, and they will be also getting a very good experience. I now request you to please continue the session, sir.
Thank you so much, ma'am. I hope I'm audible.
Yes, sir.
Yeah. I need the host access to share the screen.
Yeah, it will be done, sir.
Yeah. So, very good afternoon, all of you. And so, in today's session, we are going to talk about the aerodynamics of the electric vehicle, or even it is similar to any ordinary vehicle as well. So, we are going to discuss about the aerodynamics of the vehicle in this session. So, just let me share this screen. Can you just confirm if the audio is screen is visible?
It's visible, sir.
Okay, 1 second. Okay. Yes, is it correct?
Sir, you could go it to slideshow, sir.
Yeah, it's
Yeah,
in
yeah.
slideshow mode.
Right, sir.
Yeah. Okay. So before starting with the actual part, and that is aerodynamics of electric vehicle, and followed by that we are going to have a actual demo in ANSYS Fluent, where we are going to understand about the how we can perform aerodynamics analysis for the vehicle part over here, or EV we can say. So before that, I will just give you the quick idea, or you can say the introduction about the ANSYS, what all things we can do specifically for electric vehicle with the help of ANSYS. So that could be of more importance for you when you work in a EV section. So definitely if we say this is a era of electrification, we can say right now. So everywhere a lot of developments are going on, a lot of research is going on in EV sector. If you see different state governments as well as central governments are also coming up with different schemes where they can trying to develop different research labs, or excellence centers in case of for the electric vehicle. So definitely for as a researcher, or as a academia person, so lot of scope is there in this specific EV section. So I hope you already got an idea. So I think there were even few EV sessions in the morning, as well as there are few sessions are in upcoming days. So definitely we'll get a clear idea about the different parts of EV, or different sections where you can have your interest, and as per your interest you can continue in the different fields. So starting with that, definitely answers can help you a lot during the complete EV simulation, we can say. Okay, so in this case we can definitely, in this case, definitely you will get a complete idea from answers how it, and definitely it will help you in the different aspects to continue with your research. So let's start with this. So we are going to discuss about the answers first of all, then what are the answer solutions we have, then what are the answer solutions we have for the vehicle or electric vehicles. Then we are going to discuss about the EV external aerodynamic simulations. Oh, that is our topic for the this particular session. Then we'll be actually having a demo, and then we'll discuss what are the different research areas in EV section we have, and then just a quick idea how you can learn the answers and different skills, from the answers portals. Okay, so let's start. So first of all, ANSYS, it is a leader in a simulation market from past 50 years, we can say. It's a number one in the simulation market, and it is completely focused on the simulation part only. So there is nothing like any other business that ANSYS does apart from the simulation. So ANSYS is two times larger than any of its nearest competitors. So we can say this is also one of the best thing that we have over here. Okay, and again ansys has proven multiple times that it is capable of doing the variety of simulation in the various domains of engineering. You can take example of mechanical, electronics, then civil engineering. So various streams are there where ansys is useful. Then again, uh, ansys has up to 89% customer satisfaction globally. Then there are more than 4,800 capable employees that ANSYS is having, and of 85 ANSYS offices are there worldwide, and 150 plus channel partners ANSYS has. Now, let's talk about the pervasive simulation. So how pervasive simulation helps for the complete product life cycle. So what is a pervasive simulation? So it is a continuous simulation with all the physics across the entire life cycle of the product. Okay, so what exactly it means? So let's start with the any example. Let's say you are starting a certain new product. So in that particular case, you first of all you have to go for the ideation. So you can use the tools which answers has like discovery, that helps you to go for early stage design. So in the early stage of design phase, you can say up to 80% cost you can reduce with the help of discovery tools. Then we have another stage of the product, that is an actual product development. So it is again very important to save the time, since it is a complete market, competitive market, where if there is a delay of a day, or we can say few hours also, it is really matters a lot in the in this particular competitive era, right? So here for in product development, we have softwares, embedded softwares like skate, that helps you to validate the product much faster, as we can see in the actual scenario. Okay, then we have another stage, that is design, where we actually develop the product. So here we can reduce the development time by 9 times of the actual development time, and we can even reduce the warranty cost up to 89% most likely. Okay, with the help of tools like ansys mechanical and ansys safety. So definitely those are helpful for the design stage, and which are the ansys flagship products that we have. Then for the manufacturing, you can use the ANSYS tools like ANSYS additive pre-post or ANSYS additive tools. Okay, so these can be helpful for you to optimize the product, so that where you can reduce the weight of the product by 25% through the topology optimization in the additive manufacturing session. Okay, then the last stage is operations. So in the operation, even you can increase the performance up to 10 to 20% in the maintenance cost. Okay, reduction can be done with the help of a tool like digital twin, which answers is having that simulates the things for the real time, and you will be getting a real time data from this ansys digital twins. So I can say ANSYS is a market leader across the individual physics in with the industry leading platforms. Okay, across all the major physics. Okay, so ANSYS has its own material library. So in this particular situation, or we can say in the competitive scenario, so you to have a better optimized products, or to have a better optimized solutions for any particular problem or for the products as well. So you should have first of all good material library. So if you see now this in this particular COVID situation, it was such a critical situation everywhere. So we were even unable to get the ventilators, or the O2 concentrators. So if you see, if you take example of O2 concentrators, so nowadays those are very bulky, and we can say they are over designed with any existing material, just which is easily available. But it is not actually R&D is not actually done in that case, so that it can have some lighter weight, and it can even sustain for the better performance as well, with where we can have more capacity for the multiple patients. Like these kind of things are not done. So now the research is started, and definitely material information is very important in that case to optimize the product for the better weight, as well as for the better optimization. So definitely ANSYS comes with a granta material, which comes with the more than 4,000 material library, inbuilt material library. So definitely that can be helpful for you to do your research in the various sections. Okay, then these are the various physics in which ANSYS actually deals. So you can see we have fluids, structures, electromagnetics, semiconductors, then embedded softwares, and the opticals. Then these are the various tools. I'm not going to discuss in detail. So these are the various tools in the different domains where ANSYS provides this solution using these tools. Then these are the various world-class companies. Those are leveraging the ANSYS platform. So you can see the companies are from the aerospace to defense companies, where thousands of the customers are ranging from the well-known brands to the capes startups in the world. So all are using the ANSYS platform for their innovation. Then again, various academic institutes in India, those are also using the ANSYS platform. So this is one of the, we can say, the partial list of the customers. So we can say AP Shah is also one of the customer of this ANSYS portfolio. So definitely there are a lot of in scope you have to develop yourself or go for the research area as well. Then taking one of the example again from the electric vehicle designs part. So here it is how improving the EV design with the multi-physics simulation. So this is an example from the Lucid Motor. So see, the goal of the Lucid Motor is to leapfrog its competition and create a luxury electric vehicle. So Lucid's executives knew this, that ANSYS simulation can help you to achieve their goals. So they simulated the motor and the battery packs, as well as the car's aerodynamics and inverter coolings, uh, leading to a double digit increase in the efficiency. So you can see they have achieved up to 12% efficiency in the production, we can say, or motor efficiency, which is one of the great breakthrough that they have. So what this Lucid Motor CEO says, that ANSYS multiphysics simulation platform helps us to see the system model integrated. Okay, and that has been a key to the significant breakthroughs that we have made at Lucid. So definitely it, simulation can help you a lot in any in any different aspects. So definitely we have to go through the different simulations. So talking about the different mechanical simulations or mechanical tools that ANSYS provides, and that can be helpful for you in your different research areas. So first of all, we have the modeling tool, that is a SpecClaim, so where you can do the modeling for the various product, what are the different models we have, that you can easily model with the help of ANSYS SpecClaim. Then we have different meshing tools. These are only for the mechanical part, so that we have workbench meshing and the composite tree. So these are the composite tree posts. These are the they creates complex shell and solid composite modules with the appropriate fiber orientation and layout definition. So and here we can even perform the finite element analysis on the composite models and post process the results which are significant to the composite, such as we can say the failure criteria and all. So these things can be easily simulated with the help of for the composites as well. Then we have the various solvers like implicit epidl, mmepidl, optimization can be done, 3D printing solver also we have, then multi-body dynamics, explicit dynamics for the crash test or the drop test, where we have the LS-Dyna or Autodyne tools. Then post processing can be done in ANSYS mechanical composite post Insight. Then we can do the optimization of the products. Then we have various ACT tools that helps you to customize the workflow, and that can give you the faster solution. Then we have workbench multiphysics, where we can easily transfer the data from one physics to another physics, and definitely that can be helpful even in case of EV, where you want, if you wanted to find out the effect of air on the surface of the vehicle, or in any different problem. So in that case, you can take a help of a workbench multiphysics, where you can transfer the data from one physics to another. Then for ANSYS fluids, we have again different products. First one we have SpecClaim. So again, it is a modeling tool. Again, here it is very important in case of CFD to extract the fluid domain or do the state disclosures or the modeling in case of external aerodynamics. So SpecClaim is also very important in case of the fluid simulations. Then we have the different meshing tools, the ANSYS sorry, for the CFD problems, that is workbench meshing. Then we have fluent meshing, then TurboGrid, ICM, CFD. So these are the different meshing tools we have. Then we have the various solver, fluent, CFX, Scankin, FinSap, Bytes, and Polyflow. Then we have the different post processing tools like Insight or CFD post. Then we can do the optimization again for the same problem for better performance, etc. So that is also very easily possible. Then we have again ACT tools that helps you to make a guided work. Like I will show you how you can customize your workflow, or how that be helpful for you work on particular problem, something like this. So for that, you can have your own workflow, or you can create journals. That is also possible in the different tools. Then again, multiphysics is also there for the multiphysics simulation. Then, as I told, multi-physics simulation, so that can be done very easily like this. If you take example of this Tetra Pak over here, so due to the lid was provided inside this Tetra Pak that is getting empty, and because of that, the stresses are generating on the surface of this Tetra Pak. So as you can see, there's two-way coupling between, like continuous data should be transferred from one physics to another physics, and that can be easily done again with the help of workbench multiphysics, where you can easily transfer the data from one physics to another. And we can say that is one of the mm, very best advantage that we have of for using the workbench. Okay. Then talking about the electric vehicles. So for electric vehicles, engineering systems, and there are multiple systems, or we can say the subsystems are involved in case of vehicle. So this simulation impacts all the critical areas of ground vehicle development. So talking about the exterior, so in the exterior we have the aerodynamics, aeroacoustics, then thermal management, water management and soiling, then structural integrity. Then talk the interior, so we can go for the climate control or HVAC, then cabin acoustics, passengers comfort and safety, ergonomics, electronic reliability. So these are the various things that can be simulated for the interior of the EV. Then for the chassis, we can go for this chassis structural analysis. Then we can perform for the passenger safety and crash test. So that those things are also possible. We can simulate venting parts, brakes, suspension and steerings, wheels and tires. So these all things can be simulated. Talking about the battery and motors part, which is just replacement for the drivetrain in case of the EV, right? So in this case, we can do the simulation for the battery packs. We can go for the simulation. We can do the battery management system simulation, battery thermal management systems, then electric powertrain and charging. So these all things can be, these all things under the battery and the motor systems. Then we have the last, that is electrical. So in this we have wiring and furniture, infotainment. Then we have ADAS systems, sensors and antennas. So these are also very important in case of the any electric vehicle. Then we are going to focus on the exterior. So since today's topic is about external dynamics, right? So we are going to talk about the exterior part. So where we have the simulation capabilities that require to realize this benefits. So what are the benefits that we can get with the help of ANSYS for the simulation of exterior part of the EV. So first one, we have external aerodynamics. So with the help of ANSYS Fluent, we can go for the external aerodynamics simulation. Then again, we can simulate the aeroacoustics problems in the same. Then we can go for the thermal management. That is, we can simulate the battery for the thermal management. So I think we have this topic in tomorrow's session. So definitely we are going to discuss about the battery thermal management system in that particular session, right? Then we have water management and soiling, then structural integrity. So these are the very important parts in case of external exterior system that any vehicle has. Okay. Then what are the different ANSYS capabilities that helps you in case of the external aerodynamics? So talking about the external aerodynamics, what are the different engineering challenges that we face? First one is a drag reduction. So we have to check for the increasing range and the economy, minimize the power consumption. So this should be the target in case or the, we can say, the challenges in case of external aerodynamics. Then again, uh, quantifying the drag for all the vehicle configurations. So for that, how ANSYS can help you? So we can have a speed up simulation with the help of automated pre-processing and solution strategies accelerated with the high performance computing, that is HPC. Then again, we can get the accuracy with the help of different turbulence models. We can say advanced turbulence model that ANSYS is having, like you can say the K epsilon, K omega, or we have LES, DS with high accuracy models. We can even solve for the better accuracy, and we can get a best results. And these are the these particular turbulence models are robust solvers for the best practices. Then optimization can be done with the adjoint solver for the in the CFD itself. Then what are the outcomes that we can expect? So we can identify the areas of high drag contribution. Along with that, we can find out the complete drag distribution, drag coefficient. We can find it out. Then we can find the lift coefficient, various vehicle forces, then velocity distribution around the vehicle, or pressure distribution. So all these things can be found out for the external aerodynamics. Then talking about the aeroacoustics. So again, here we face the challenges where we need to identify the noise sources. We need to check out for the aerodynamics noise quantification, and how we can reduce that we need to understand. So here again, we can go for the predicted noise from the multifidelity compressible and incompressible physics based models are available for this. Then again, here also HPC is possible, that is high performance computing is possible, so that we can get a faster results. Then we can get the outputs like sound, pressure level, at key receiver locations, means at in key locations we can get the sound pressure levels, then we can get the noise source location, magnitude and flow structures, then we can get the broadband spectra, octet bands, then filtering, windowing and signal processing. So these things can be easily found out with in case of aeroacoustics problem. Then third one is the thermal management. Here we have to check for the trade-off between the aerodynamics and thermal management. Then we can even need to check for the cooling system design in a confined environment with a wide range of operating conditions. So here again conjugate heat transfer modeling, CHT, with the advanced radiation and heat exchanger and fan capabilities. So these all things are easily possible with the help of ANSYS Fluent again. And here again we have one of the Fluent meshing tool, so where we have automated meshing workflow for the complex and dirty CAD models as well. So definitely that is also very useful in this case. Then talking about the uh, sorry, so what could be the results that we can get for the thermal management? So we can get a cooling system performance and the identification of the problem areas where how we can overcome those things, we can easily analyze from those results. Then again we can go for check for the cooling fan power requirements, for the proper cooling of that specific locations. Okay, then water management and soiling. Then in this case, economic and relatable water management and soiling need to be done. Then quantifying the effects of water and soiling on the sensors performance, so those things need to be found out. So again here we have the accuracy, where we can go for the extensive multi-phase model. So with the help of that we can very easily simulate this water management problems. And again mesh adaptation to accelerate the multi-phase solutions is also possible over here. Then you can even go for the coupling soiling with the sensor performance modeling. So multi-physics also can be done over here, like you can couple fluid as well as electromagnetics or HF or LF part with the help of multi-physics too. Sorry. And then here we can get results like soiling pattern, water bedding, load, quantification of sensor degradation. So how those things can be easily found out over here. Then the last part in the exterior is structural integrity. So here we have to find out or check the structural performance versus the weight and cost for the particular vehicle. Then material selection for the vehicle life cycle, that is, as I told, material selection is one of the very important parameter over there, right? Then forming the complex body panels, these all things can be done with the implicit and explicit solvers and detailed material modeling including the composites. Then again fluid structure interaction, that is FSI for realistic loading, also can be simulated with the help of ANSYS mechanical and ANSYS CFD tools. And then optimization and additive manufacturing, so DOE and topology optimization with design to print additive manufacturing workflow is available, so you can go for that as well. Then material management, so as I told, we have Granta MI, so definitely that helps you in this particular regard. So I'm just giving you the brief idea, like what are the different tools can be useful for a different problem. So then we are going to discuss about the aerodynamics part, right? Then with the help of that we can get the optimized design, we can check out the fatigue life, we can even go for the predicted thickness of formed parts, then we can even have the material innovation. Now talking about the AV exterior external aerodynamics. So first of all, aerodynamics, so in automotive, aerodynamics is a study of the aerodynamics of vehicle on the road, right? So in this particular you know mm, part we can get the result. Main goals are to reducing the drag and wind noises, then minimizing the noise emission, then preventing the undesired lift forces and other causes of aerodynamics, instability at high speed. So these are the our main motto, or you can say the important things that we have to do over here. Okay, in case of aerodynamics part. Then external aerodynamics, which is one of the main application in the automotive industry. So previously the CFD was used in wind tunnel experiments to optimize the shape of cars in terms of lift and drag, and to study the salient flow features. But now in the last few years we can see the simulation of aeroacoustics that has become another major application that helps the aerodynamicist to obtain fast and reliable results for a specific configuration. So definitely it is of very important. So what are the different challenges that we face in case of external aerodynamics analysis? So what are the different customer goals over here? So first one is to predict the drag, lift and moment forces acting on a vehicle to help improve the fuel efficiency and to increase the vehicle stability. So this is important part over here, right? So that is the main goal over here for the external aerodynamics simulation, right? So solutions over here, we have automated cat to result workflow, and that reusable and robust workflow for creating fast and quality mesh, solve and post processing. Here we can use the fluent meshing, we can use the fluent solver, as well as we can use the Nsight for the CFD post, that is post processing the results. Here we can go steady state solution for quick evaluation of aerodynamic performance for geometry design iterations. You can even find out the unique tunable turbulence model for the improved accuracy. So that is also available over here. Then we can go for high fidelity transient solver as well. Okay, using unique Gecko and SBES turbulence model. So which are high accuracy turbulence model that ANSYS is having. Definitely with the help with the high accuracy, the complexity of the problem, or we can say the convergence, also becomes difficult. But it is for specifically suggested for the HPCs, like you can use it with the help of HPC. Then we can reduce the 75 percent reduction in the number of wind tunnel testing. So external aerodynamic studies, those are done in the early stage of the vehicle design cycles, where the styling is not yet finalized. So or after the platform is launched for the some facilities of the baseline model. So initially what they do, initially either a scaled down model or a full scale model is tested in a wind tunnel, and again simultaneously simulated to validate the aerodynamic performance parameters, like we can say drag, lift or momentum. Then subsequently simulations are performed on a multiple design iterations of the vehicle with the different modifications, different ORVMs, air dams, spoilers, etc. And then the best design is finally validated with the experiments. So typically it has observed that the ratio of experiments to CFD runs for different cases is 4 as to 1, and that can impact much higher 10 as to 1 or more for some OEMs, where large number of different design iterations are studied via CFD. Okay, so if we considering typically 4 simulation CFD simulations per every one experiment. So how it can say, so we can say 75 reduction in the cost of the wind tunnel testing. So that is how it is very useful for you to go for the simulation. And here again we have the flexibility of the fast steady state and high fidelity transient solution with the unique tunable Gecko turbulence model. So definitely that helps you to give you the better optimized results. Again, it is a fast and robust workflow that reduces the overall design cycle times as well. So if you see and mesh generation that is possible with the help of fault tolerant meshing as well, with the help of wrap up technology, for the volume mesh in a batch mode. So this thing is also possible over here. So it's like, batch mode is like when fluent meshing UI window is not visible, the script run in a background on HPC or a cluster, or any local machine. So that is how batch mode works. So definitely, even for the fault tolerant, you know uh, meshing can be done for the uh, not completely repaired models. Okay, so even with the some faults also that is possible. Then again we have the solvers. Once we create the mesh, that we take that particular mesh to the solver setup, and we run again, that can be run in a batch mode and we get a solution. Then again post processing can be done. We can even take the solution to the insight where we can do the post processing part over here. Okay, so you can get a various results like pressure coefficient on car surfaces. Then you can get a cumulative drag uh, along with the different direction, along the flow direction. Then you can get a iso surfaces for the total pressure. We can get a velocity distribution, then pressure distribution, various controls we can plot. Then we can even animate the velocity controls. These things are easily possible for the external aerodynamics problems. Then now how we need to start for the simulation in case of external aerodynamics problem, right? So first of all, geometry that we'll be having, like you may take even a clean geometry into the space claim, or if it is not clean, then you have to do the geometry cleanup in the space claim. Then you have to set up the name selection for the different boundaries. Then you have to take that particular clean model, or you have to transfer that particular model into watertight geometry workflow in the fluent meshing. Again, we can create a mesh for that model. Again, if you want, you can save the same mesh workflow for any future mesh edit or any mesh automation. Like if you are going to work for the multiple cases in a same way, then you can save that particular workflow as well. Then you can load that mesh into the fluent, and then you can solve the problem. Then you can save these complete simulation workflow in a journal file. So for future simulation, again it can be used as an automation. You can directly call that journal and automatically it will give you all the inputs what you have given, right? Then post processing can be done in the fluent, and that can be exported into ANSYS Insight or CFD post, where we can do the post processing. Okay, then now I hope you understood the complete idea how exactly we need to uh, start with the simulation. Okay, so let us discuss about the meshing that can be done for the that can be done with the help of ANSYS fluent meshing, and which is very important in case of, I can say, the vehicle, or any vehicle. You can take EV or any other vehicle. Since if you see any vehicle that used to have lot of complex shapes, we can say, and definitely for that meshing is creating a meshing is one of the biggest challenge, we can say, right? Because if we get a good meshing, then definitely we can get a good results, but getting a good mesh itself is a big task, right? So definitely for that purpose, we have ANSYS fluent meshing. That is a very good we can say very good tool to create a mesh. So as I said, simulation challenge that we face is we require a high level of accuracy and their aerodynamic simulation for the complex geometries in even a shortening time frames. So what it means, we need a faster solution, since we wanted to solve it fast, so that we should have some tool that should handle this complex geometries that produce high quality mesh. And again, it should have fast turnaround time. Again, we can have customizable, repeatable and deployable mesh features in that particular mesh tool. So for that, we can say how we can handle these different mesh tool meshings, or how we can fulfill these different meshing requirements. So for that we have answers fluent meshing. So that that helps you to get a faster mesh. We have the different types of mesh elements, those are possible, like tet mesh, polyhex core, polyhedral hex core mesh. So different mesh types can be easily created over here. Again, it is a faster meshing, like you can say up to 10 times faster, or even more speed up can be done in the in this fluent meshing. So definitely, again, it is a having a customizable workflow, so you can go with the customizable workflow based on the type of model that you have. Like you have watertight geometry or fault tolerant geometry, like it's not completely watertight, or it's not completely repaired. In that case also we can say you can even go for auto meshing. There we can use a wrap-up technology, and with the help of that we can easily extract the fluid domain, or you can create an enclosure and you can do the further processing. Okay, again, ANSYS has experience of working with many OEMs and motorsports teams, and that have established the best practices. So definitely all these tools are already tuned for the better performance. So with this, I will just give you a quick introduction about the mosaic mesh. So just have a look at the video.
Great engineering, like great art, reflects
Audio is there. Are you getting audio? Can someone confirm me?
Yes, sir. Yes, sir. Continue.
Okay. Okay.
the world around us. Its nature, its detail, its beauty, its design, all come through in an elegant and accurate expression of reality. And like great art, great engineering demands its own set of solutions to paint the perfect picture. Introducing Mosaic from ANSYS. Solutions that optimize the mesh everywhere. Solutions that don't compromise accuracy for speed. Automatically connecting any type of mesh using polyhedral elements for fast and accurate flow resolution without compromising the ability to place the optimal mesh in every part of the volume. This powerful new fluent experience delivers higher quality cells 45% faster while requiring 30% less memory. Already the most widely used and dependable CFD simulation tool in the world. ANSYS Fluent now easily and quickly conformally connects any mesh type, complex geometries, and flow regimens, allowing you to explore more materials, more variations, more possibilities. And like all great works of art, simplicity, beauty, authenticity, they fit together perfectly and show us the promise of a new tomorrow.
Okay, so I hope you got an idea about this mosaic mesh technology that comes with the ANSYS Fluent, and definitely it is really helpful to create a mesh. So now you can very easily transfer the model directly from the speculum itself to this watertight geometry workflow with the directly from the speculum itself. So this way you can easily transfer it. Yes. So you can see this option you will be having. So where you can directly transfer the model to ANSYS Fluent Meshing. Okay. Now here you'll be having two different task-based workflows. So one is for watertight geometry and another is for fault tolerant geometry. Okay, so again both are easy to use. Again, best practices enabled at each task, so you can what it means is like whatever the minimum, or we can say whatever the options required to complete any meshing in case of watertight or fault tolerant meshing workflow. So both are already added over there. It's like you have to just follow the given steps and you will be able to get a good quality mesh over here. Again, the workflows are customizable. Even you can even add any other specific data or specific things if required based on you. Okay, so that those things are also possible over here. Again, for no watertight geometries, for dirty geometries, non-watertight geometries need to be taken. Here it works with the help of wrap-up technology. So it actually encloses any holes or any gaps over there, or automatically we get a complete watertight model in the fluent meshing itself. So no need to try to make it watertight model also. So that is also possible. Again it is efficient for the parallel meshing. Both are efficient for the parallel meshing. Again, only the prerequisite for the watertight geometry for workflow is you should have a clean watertight geometry. Okay, whereas here in case of a fault tolerant workflow, it is not required to have the watertight, how we can say, geometry. If it is not watertight also, it is fine. Okay, so here it automates with the Python based journal file, so you can even save this in a journal file as well. It's like automated. Once you save the journal file, if you wanted to use it again, you just need to import a new model and just import no call the journal, so it will automatically start applying all the settings that we need to apply manually. Okay, so it helps you to reduce the repetitive work for this. Okay, and then uh, yes, so this you can see this is the mosaic mesh technology, how exactly it works. Okay, so on the wall surfaces, we can say, here you can see on the wall surfaces it creates a poly or prism mesh over here. Okay, in the free space and or in the middle part, you can see what you can see in the yellow color there, it creates a hexahedral elements. Now this is in case of polyhedral polyhex core mesh, I am telling. Okay, so this is on the surface it creates polyhedral elements, then on the middle part, in the, we can say, in the volume, it creates the hex core elements or hexahedral elements. And then whatever this green color, you can see this is the mosaic mesh, so that actually connects the polyhedral and hex core mesh together with the help of mosaic mesh technology. Okay, so that is very efficient, and it reduce the solution time by 30 to 50%. Again, you can get a better quality volume mesh. But the limitation over here is it is not this meshing technology is not available for 2D problems. Okay, so it should be like you have to solve it with the 3D only. Okay, for 3D only this mosaic mesh technology is applicable, or fluent meshing is available. Again, as I told, it is much faster. You can say it creates 2.5 million cells per minute with 16 cores if it is working in parallel. So you can see how faster it is and how faster mesh you will be getting. So it's like, you can very easily create in between 10 to 20 millions mesh with very less time. Okay, and again, even it don't need the HPC licensing also, so that you can go even in parallel as well. Okay, then uh, as I told, I'm just discussing about the EV section only. Okay, so whatever these things I'm discussing, those are specifically very important with respect to EV. Okay, so here another part we have, that is the electric motor meshing. So for that, meshing can be done 4 times faster. Okay, so again, which is one of the important part, you can say, or add-on part in case of this fluent meshing we have. Again, for battery simulations, it creates a very good mesh, as well as you can do mesh copying over here. So what exactly it is, if you see any battery pack, it consists of the number of cells. Let's say any like a single battery pack, or if you know the EV electric vehicles, so they used to have multiple battery packs in that particular EV in the bottom side, right? If you have seen. So in that particular, in each battery pack also, there will be some hundreds or hundreds of the cell will be there, right? So those will be exactly identical to each other. So in that case, what you can do is you can copy the mesh from one cell to another. So it it works in a such a way that like you can create a mesh as fast as one cell, so for hundreds of the cells. Like what it means, you just need to create a mesh for a single cell and you just need to copy the mesh to another remaining cells, remaining identical cells. So it's just copy and paste for the remaining cells. So this is how faster it works, as you can see over here as well. So very easily it just creates a mesh. So you just need to do the copy paste over here. Then these are the few examples of mosaic meshing. So to understand the how it works. Then again, parallel stability, you can say it works really great for the different problems as well. So you can get uh, some millions of the mesh with a very less time. So you can say uh, 100 million cells per minute with 256 cores. This is this much faster it gives. So you can understand, if you have already worked on different problems, so you'll understand the time taken for any problem to solve. So definitely it is really helpful in that case. You can say 15 times faster mesh you can get with the help of ANSYS fluent meshing. This is one of the example where this actually we are going to solve the same kind of example. So for this, you can see this is how the mesh is being created. You can see this particular layer here. You will be having the this mosaic mesh on the. Then again here you will see on the wall, near the wall you'll be having the hex polyhedral elements, and these are the hex core elements that you can see over here. Then talking about the ANSYS Fluent again, which is the industry leading computational fluid dynamic software that is known for its advanced physics modeling capabilities in the industry lead, and it gives the industry leading accuracy as well. So it again accelerates the processing for from CAD to mesh to accurate results with the features that increase the productivity while enabling more innovate innovation, but never compromising with the results part. Okay, so definitely we can say this is a really good tool that we have here. Then talking about the different turbulence models in ANSYS Fluent, that can be helpful for the EV side. So again, based on the type of the problem we are considering, we have the different models, as I told. Okay, so generally we have the one. Generally we use the one or two equation RANS models, that is Palatalmas, K epsilon, and K omega. All right. So all these models are available over here. Again, if you wanted to go for the unsteady problems, we have the scale resolving simulation methods, where we have the LES, DES, SAS. So different models are possible for the unsteady problems as well. Then we have Gecko, as I told, that is generalized K omega turbulence model, so which is very important over here. So this Gecko that is developed by ANSYS is a new turbulence model family. It is from family called generalized K omega model. Okay, with the goal of turbulence model consolidation. So Gecko is two equation model that is based on the K omega model formulation, but with the flexibility to tune the model over a wide range of flow scenarios. So this is very important in case of flow, or we can say the results in the critical area. So definitely that can be helpful. Then when we are talking about the EV solution, so battery related models, so we are going to use this model in tomorrow's session, but I'll just tell you. So previously this was an add-on module, so now it is directly introduced into the ANSYS Fluent model section. So you can directly access that specific model in the from the model section. So which is again we can say one of the add-on over here, and it's really important in case of the battery simulations. Again, then high order term relaxation, that is HOTR. So this it is which is applied to higher order discretization terms, that is pressures. It can be a pressure based or the density based. So what exactly it does, so it improves the solution convergence behavior for second order discretization. So when we go for the second order discretization in the solution method, so that helps you to improve the solution convergence behavior. Okay, again it helps to prevent the apparent convergence stelling. Then again it improves the solution startup robustness as well. So like it gives you more smoother results, we can say. Then it can be directly activated from the solution methods task page. Okay, and again there are some extra options are also available inside this. Then now let's move towards the demo side. So we will be solving this vehicle model. I hope it is already shared with you. So we have a CAD car, and then car wing something, this two different models that I have shared with you, right? So here we are going to consider this EV which is moving with the velocity of 22 meter per second, that is 72 kilometer per hour, right? So we are going to find out the different forces that this vehicle is going to experience. Okay, so I'll just stop sharing and I'll share another screen. So let's start. So if I'm not aware if you all are going to do along with me or how it will be done. So if someone can confirm me.
Sir,
Yes.
some of them.
Yes, please go ahead, sir. I think there is some echo from your side.
Hello.
Yes.
Yes, sir. Some of the participants will be going with you, and
Okay.
remaining will observe it.
Okay, right. So if in any case, if anyone faces any difficulty to access, you can let me know. I can see in a chat only one file, but I have shared almost 3 to 4 files. So if possible, you can share all the files or
Yes, sir. Yes.
either over here or through mail. Actually, this file is not required. Just for safer side, if anyone is not able to create a mesh, then they can go with this car.mesh file. In other cases, we just need 2 files. I'll just tell you the names. 1 second. So CAD C car dot x underscore b and CAD C wing. So these 2 files only. Okay. So if you can share that files. Yes, sir, definitely. We are there to help you. Yeah, I think they are sharing the files and just give some time to them. They will just post in the chat. Is it possible for me to share? I am not aware of it.
I guess you can share. There's just a option there in chat box.
Okay. I got it.
Yeah.
Yeah, one is sending, another one is okay. So both the files are shared in the chat if you can check it. Okay, so let's start. I'll just share the screen again. I can share the full screen, right? Or is it? Can you see the screen completely?
Yes.
Okay, so first of all, those who are completely new to answers, I'll just give a quick idea. So to start with answers, you just need to go to the start menu and you can just search for workbench. Which version you are using? Can I let me? Can someone tell me? Yes, which version of answers?
Trial was in 2020, I guess.
Okay,
R1.
20 R2. Okay. Someone texted 20 R2. Okay, that is fine. I'm using ANSYS 2021 R1, so there won't be any difference at all in the two versions. Okay, so you can just follow me. I'll just share the screen again. Okay, so this is, so you just need to search for Workbench 2020 R2 if you have, or I have 2021 R1. If you just type Workbench, so you'll get this particular over here. Okay, so this is Workbench 2021 R1, which I have already kept open. Okay, so now whatever the CAD models or whatever the files I have shared, those are the parasolid file format, that is X underscore B. Okay, so what you have to do is, if you see, yeah, this is the X underscore B, these two files I have shared with you. Okay, so these are in a standard file format, not in a Workbench, or we can say the Speclum file format. So what you have to do is, first of all, you have to import those files into the ANSYS and you have to repair that. Okay, so if you know, like the data losses during the transfer of the files, right? So in CAD or CAM, I think you will know this part, right? So start with this. So I'll just take a analysis. I'll take a component system, that is geometry. So just drag this geometry and just drop it over here, and then just double click on geometry to launch the specimen. Okay, so here you can see on the bottom side it is showing starting specimen. Okay, so it's launching, so we just need to wait until it will launch. Yes, if anyone has any doubt, you can just let me know. Sir, you can just check in this chat itself. Here I have shared the files. I hope you can see. You just need to click on it to open, or you can just open files, or you can just download it. So you just need to click on it to download. Okay, so you can easily download the file. Okay, so here you can see Speclum is open now. I'll just switch to the Speclum tab. Can you see the Speclum? I'm not aware the sharing part over here. Can someone confirm if Speclum is visible?
Yes, yes, it's visible.
Okay, okay, okay. Okay, so start. So I'll just go to the file and I'll import that file. So you just need to go to the file, open, and in the open, you just need to first change this filter from .scdoc, which is a Speclum file format, to all, because we are importing the standard files, not from the Speclum. Okay, so select this all files option over here, and just browse to the folder where you have downloaded it. Okay, I have downloaded, I have file over here, so I'll just, okay, so this is a CAD C car X underscore B. So this is a parasolid file format. Select this and open it. So as you can see on the bottom side, it will open that complete file over here. You can see the status, it is saying importing. Okay, so okay, it's importing thing. Yes, so file is imported. So you can see this is the car model that we have over here. Okay, so now first of all, we need to understand what could be the different data losses over here before starting repairing that particular model. Okay, so here we are going to create a complete watertight model over here, and then we are going to create an enclosure around it, and then we'll be moving to the machine. Okay, so let's see over here. If I'll just go to this repair tab. Okay, so you have to move to this repair tab. Before that, if you see in the structure side, here we have two surfaces over here. Okay, so first thing what you need to do is you have to observe, like where these are located. So you can see this surface is reflecting separately, and this is another surface, right? So first thing you can observe that both the surfaces are splitted. Okay, so you need to stitch them together. So for that, we have this, use this stitch option. So select the stitch option, and here you can say it will show you found one area. So just click on it, or you just click on this green tick also. Both will repair this model. Okay, so you can see now it is repaired. and here you can see only single surface one. Okay, so the model is stitched. Then check for the gaps. Second thing, so here you can see again it is saying found 3 areas. So select the first one, repair it. If you want to repair all at once, then just click on this green tick, or if you want to repair one by one, select one by one like this. Okay, once the model gaps are filled, then check for the missing faces. So here you can see it is showing found 6 areas where faces are missing. First one is over here. You can see it will start adding the faces. Okay, so second one is over here, and this face is missing. Okay, when you will add, you will get to see the face will be added. Similarly, here also you have to add the face, then right side, and here also small gap will be there. Okay, I hope you can see this gap. Okay, so this is the face missing over here. Okay, and then the last one is over here. So as you can see, when I have added all the missing faces, you can see that surface body is converted into a solid body. Okay, so we have successfully repaired all the faces. Okay, now what we need to do is we have to call the wing shape as well. So before that, still we have to repair this. Next one is the split edges. So you can see there are 15 edges which are splitted. So what exactly this works? So if we don't create or if we don't repair the model, so what will happen? See, the meshing that we are creating, that will not be up to the mark. First of all, if it is not a watertight geometry, we will not be able to extract the fluid domain. So that is the first thing. Now second thing is like if it is a watertight but it is like it's still having some other issues like a split edge or extra edge, that will lead to some bad quality mesh. So we have to repair that model before going for the meshing. Okay, so here you can see we have to repair the different split edges. So if you see, I'll show you one by one. So this should be a continuous edge, right? But it is splitted into two parts. So just combine it to one. Again, over here, you can see it is splitted at this location. I'm just showing you. Otherwise, you can just go for all at once. Okay. Here also, it is splitted at this location. Also, it is splitted. And then over here, and then here. Sorry. Okay, all are repaired except this one. So it is not repairing. So for now, just leave it as it is. Okay, then go for the next, that is uh, extra edges. So no extra edges found. Any duplicate face, so no duplicates are also found. Okay, so we have completely repaired the model. Now we have to add the wing shape to this particular model over here. Okay, so for that you just need to go to this assembly and go to this file, so you can import another part, that is wing. So select this CAD C wing and just open it. Again, it is a parasolid file format. So when we are importing it, again we have to repair that particular model as well. So just I'll hide this car body. Okay, and I'll just show you this wing shape or wing over here. And again we have to go to the repair and we have to repair the wing. So stitch, no stitch are there, no gaps are there, missing faces, one face found. So just add it, and now you can say it is repaired. But if you see this specific surface of this added surface over here, that missing face which is added, if you see how it looks like, you can see it is not a straight one. Okay, it is like this kind of wave shape it is taking. Okay, so that's why we have to first even repair this as well. Okay, so for that what you can do is you have to first of all we'll check other parts. No extra split edge, no extra edge, no duplicates. Now go back to the design. Now what we have to do is we have to create a surface or plane with which we'll replace this particular surface. Okay, so we have to replace this surface first of all. Okay, so for that, first of all, we have to create a point. So now we can see here in this particular location we have 2 points, and the bottom will create a point and on this edge at the middle or anywhere somewhere on that particular line. Okay, on that particular edge. Now we have to select a plane. So we just don't need to create a plane, we have to build a plane. So select this build plane option over here, and then select these points so that you can create a plane which is passing through those points. Okay, and now third point, select. Now you can see this dotted line over here, so just select this dotted line so that plane will be created passing through those 3 points. So you can see plane is created over here, and now you have to use this replace command. Okay, and then select this particular shape that we wanted to replace, and then select the plane to replace. So automatically it will replace that. Here you can see target faces were replaced. Now hide the plane and hide the point as well, and here you can see it is a proper straight shape that we got. Okay, as you can see over here. Okay, so it is done, model is repaired. Now we have to attach it to the car body. Okay, so again for that we have to attach this particular we have to attach in such a way that this rectangular shape that will coincide with this particular shape. Okay, so this is how we have to um, this is how we have to uh, attach it. Okay, so for that go to the assembly, sorry, not assembly. First of all we have to create a plane along this rectangle again to make it align with that particular plane. This surface should be aligned to that particular plane. Okay, so again here also we have to, I'll just hide this wing shape. Here also we have to construct the plane. So go to the plane and select the points, sorry, we have to select the construct plane option. So, go to this plane option, go for the build plane, and then select this particular point, then this point, and then 1 point from this side. Okay, it's not detecting, so first of all we have to just make a point over there. Okay, so the point is created over here, and now, sorry, not created one here. And now just go for build plane, select this, so select the point, another point, and this point. Okay, so plane is created. Now sorry, plane is not created. Select this dotted lines to create a plane. So you can see plane is created. Now again view this model and then go to the assembly and select the align option and select this surface and align it with the plane. You can see it will be aligned. Right now we have to move it and we have to position it exactly at this particular location. So select the move command, triple click on any surface to do the complete body selection, then select the anchor and change anchor position to this location. Okay, and then direction should be along this particular plane, right? So select the edge so that it will be along there. Okay. Now select the up to and select this particular point. You can see it will be positioned over here. Correct. Now we don't need that rectangular shape, so I'll just hide this plane. Select this particular shape. You should be in select mode. and delete it. Okay, so that that patch should not be there. Again view the model, and now both are combined together, or we can say we have to make them as a single body now. So I don't need these points anymore, I'll just delete them. Okay, all are deleted. Now go to the design, sorry, go to the prepare, and then click on interfaces. Now when they are combined, now you can see this shape of the wing, this bottom side we made it straight, but if you see this shape is not straight, it is little curvature. So that's why here, though we have aligned it at the points, in the middle it is merging with the another body, right? So we have to remove the interface material. Just click on it and it will be removed. Once it is done, now go to the prepare section and go for the enclosure. Sorry, not before that, we have to combine the model. So select the combine option, select first body, take combine option and select the second one. So you can see now it is combined. I don't have anything over here, I'll delete this. So you can see the single body over here. You can rename this to car. Okay, rename it car model. Done. And now we have to create an enclosure. So go to the prepare, select enclosure option and select the body. Now we can give the dimensions. So let's say we'll give in the sides. I'll not create a much larger domain, so that the time taken for this solution or for even creating mesh should be less, very less. We'll try to keep it less as possible. So I'll just give it as 1500 on the sides. On the front and back, let's say I'll give 4000, and then on top and bottom again let's give as a 1500. This I'll give as 1000 only on the sides. Okay, so this domain will be created. Now I just need to say okay to this. Now as you can see, model is created. Now in front direction, not necessarily you should have that much domain, so I'll just remove it. Again, there is no thumbnail to create any domain from for the external flow problem. So it's like generally if you refer any paper, so they generally says like it is supposed to be 8 to 9 times of the actual model, but again it varies from when you are going with a high velocity. So that also you need to check it out. I'll just reduce the size from the front direction. Let's say I'll reduce by 2500, so it will be 1500 on the front. Okay, and the bottom also it should be on a road, so I'll just remove this and again I'll make it as a 1500, so that it will be exactly on the road, as you can see. Okay, so model is created, enclosure is done. Now we don't need the car model, so right click on car model and click on suppress for physics, so that will be removed. Now as I told this that edge was not repaired, again go to the repaired and check for the split edges. Now the for this domain it will be repaired easily, so just repair it. Now if you will see, it will not show you any split edge over here. Done. This is how we can create an enclosure. Now this is the complete domain over here, and once model is repaired, we have created an enclosure. Now we have to create a name selection. Okay, first of all we'll give the name selection to this complete car model. Okay, so I'll just hide all the faces. Hide face. This will make it done. This also will hide. Okay, so it's selecting all. As you can see, I'll just go from the front side and I'll do box selection and I'll select all the faces. So go to the groups, create name selection, and we'll name this as a car. Okay, and I can right click and show all. So it will show all the bodies. I'll hide the car model again. And now this is a inlet section. So select this, go to groups and again create name selection. This is inlet. And then this is the outlet, select it. Then these are the symmetry faces. So those will be in contact, like those will be open to atmosphere. So I'll name them as a symmetry. Okay, and then this is the road or wall, whatever you want, you can name this road surface. Correct. Okay. Okay, so all names are being given as you can see over here. And if you want, you can save this car model. So just click on save as. And let's say we'll save it on desktop. Okay, so this is, we are saving in a specific file format. I hope it is clear till this. Any doubt, any question in the specific part? So now we are ready to move to the next, that is creating a mesh. Any doubt? Okay, so we'll move. So we have to take another component system that is fluent with fluent meshing. Okay, so if you see over here, so this is the fluent with fluent meshing. So you can directly attach it and you can directly transfer the geometry, but there is a issue like we cannot edit the dimensions unit. So I'm taking it separately and I'll directly launch it and then we'll import the model. Okay, so double click on mesh to launch the meshing tool. Okay, so here you can see you will be able to see the dimensions. By default it is 3D, you cannot solve or create a fluent meshing in 2D. Enable the double precision for better accuracy, go for 4 cores or how much our cores, like up to 4 it is supported for normal license. So I can give 4 cores and start. So you can see it is starting fluent. And now we have to select first the workflow over here. As I told, we have two workflows. So if you see in this, we have watertight geometry workflow and fault tolerant workflow. If you want, you can create any new workflow as well. So you can see that's what you can make a guided workflow as per your problem. So that is what possible with the help of that. Okay, then if you see GUI is similar to the fluent. On the top side you have the different options available. This is the console, this is the graphics window. When we'll import the model, that will be visible over here. And this is the outline of workflow view. Here you'll be getting the outline of the workflow when we'll select the workflow. So we have to select the watertight geometry workflow, so just select it and you can see you'll get the complete workflow over here. Okay, now first one is a import geometry. So select this, and file format that we are going to import it is a CAD file, and units are set in mm. If you want, you can change it. Okay, I want it in mm, so I'm just keeping. Then go to this browse option, that is 3 dots, and then import the model that we have saved. Now I have saved the model on desktop, whatever the CAD file that we have. So just browse that. So go to the desktop, and here you can see this CAD.scdoc. Just open it and just click. It will be directly imported over here. Okay, so as you can see, model is imported over here. you can see all the complete enclosure that is visible. First option after that, you can see import geometry is done, so here you will get a green tick. Next is add local sizing. If you wanted to add sizing at any specific location, you can say yes, and you can select the locations where you wanted to add the sizing. Okay, and there you can add it. I just don't want to because it will take more time, so I'll just say no to this and we'll move further. Okay, say no and click on update, so it will update the same. And the next one is to generate the surface mesh. Now if you see over here, it will show certain dots like these are the preview where you'll be getting the largest we can say larger size of the elements in this particular locations. So you can see one that you are getting over here as well. Okay, so that you need to understand. Now the maximum size here, it is given 3 to 35, so I'll just change it to 200. I'm not making it too small as well, okay, because it will take more time due to some time constraint, but definitely you can keep on playing with this and you can reduce the sizing. Let's say I'll take 1.8. Okay, you can change the angle of curvature to 12. Again, it gives you similar options in that we have in ANSYS meshing or workbench meshing. That is, if you wanted to capture the curvature and proximity, so you can select according. Okay, once it is done, then just I think I'll keep 200 itself. It will take more time otherwise. Okay, and then generate the surface mesh. Click on it, so it will generate the surface mesh. First it will create a tetrahedral elements, and then no, after final mesh it we will get a polyhex core mesh. There we need to select the type of the elements as well. I have taken a smaller domain. Definitely domain should be larger. I can by observation also I can tell, but since we wanted to solve it in fast, so I'm just taking a smaller domain. Okay, so first of all it will create the create a tetrahedral elements that you can see. Okay, so elements are created as you can see over here. If you want, you can just clip the plane and then also you can observe. I'll just clip it. Okay, okay, it's from this side, so I'll just revert the flip, so you can see tetrahedral elements are created. This is the surface mesh that it has created initially. Okay, that you can observe over here. Now if you give even a less size, it will even create more better elements. Okay, but due to like we have given sizing of 200 mm, so you can see this is little larger. Okay, but if you want, you can create it further as well. So then next step is to describe the geometry. Here you can see the geometry. First option in the geometry type, that is the geometry consists of only solid regions. No, like in any cases, if you just wanted to create a model and create a enclosure or a volume here in meshing, that is also possible in case of fluent meshing. Okay, so that's why it is asking these options. So we can see this model is having only fluid regions and no voids and solids. Okay, or if the model is having both solids and fluid, then you have to select the third option. So for our case, we have second option over here, that is the geometry consists of only fluid regions. And then if you have multiple fluid regions, like more than one fluid regions, then if you wanted to change the fluid boundaries to internal, that is also possible over here. Okay, so say then in that case you can say yes. And if you wanted to share the topology, then also you can say yes to this. So in this case we have single model, so nothing else need to be done. We just need to say the geometry consists of only fluid regions. Okay, click on describe geometry and then go for the next update boundaries. So first one is a car surface. If I remove the split, so this is the car surface. Okay, when I take a cursor over there, you can see it is getting highlighted over there. So that will act as a wall, right? So you have to define the boundaries. So then inlet will be velocity inlet, you can say as described. Outlet will be the pressure outlet, road surface, that will also act as a wall, and the symmetry. So these three surfaces, those will be exposed to the outer domain. So there is no restriction to the flow in these three directions, right? So that's why I have named it as a symmetry. Okay, so that is symmetry done. Click on update boundaries. If anything is need to be changed, that you have to change it over there. Okay, but I have given name selection in such a way that software is automatically detecting. Instead of inlet, if I'll just name it as a in, then also it will detect as a wall surface. So that also you need to keep in mind while giving the name selection. Okay, that actually reduces a lot of efforts. So then next one is update region. So this enclosure means this complete enclosure that we have created, it is completely fluid domain. So just click on update region and done. Then if you wanted to add any boundary layer mesh, right, that is inflation layer that we added to capture the boundary layer formation near the wall surface, right? Let's say I wanted to create 4 layers, and where we wanted to create it, let's say I wanted to create only on the wall surfaces. So which are wall surfaces? The road and the complete car model. So only along those it will create an inflation layer. So just click on add boundary layer and then go for the last, that is generate the volume mesh. So here, to generate the volume mesh, we have to select the type of the elements. If you see over here, we have type polyhedra, polyhexcore, hexcore, and tetrahedron. So here we will create polyhexcore mesh. Okay, select it and just click on update. If you want, here a lot of advanced options are available in each. So you can update the boundaries, you can add additional things. I'm just going with the simplest one. Okay, that it should not take more time. Okay, so just click on generate the volume mesh. So it will create the volume mesh over here. So this is how very easily you can create a mesh with the practice. Even a person who is not from the simulation background, he can also very easily create a mesh with a very good quality. Okay.
Can we have a local control over a mesh in this type of meshing using fluent?
Yes, this is a local meshing. So here you can add multiple local mesh settings at any location, faces, edges, or bodies as well. But it will take more time, so I have not given. So
Okay.
this is like first step when you import it is you have to give the local settings, local sizing you can give.
So there we need to give reference of named surfaces, right?
Either you can give labels or name surfaces, or you can it even it shows different surfaces as well. So wherever you want, you can easily apply it.
Okay. Like
Even for the bodies. Yeah.
in ANSYS meshing, we use the sphere of influence or
Yes,
some
yes,
other
yes.
mean.
Yeah, so
So
here we have direct body of influence. So you should have another body, and
oh,
that will be removed after the body of influence. But
oh,
whatever the part of that, this main body is which is interfering with that new body, that there you will be getting that body of influence meshing, that particular region.
that we need to create while making the geometry itself.
Yes, you have to create that as well. Like how in ANSYS meshing we create a sphere, but that is
Yes.
easily possible. But in this case, you have to create it in a modeling itself.
Right, right.
Yeah.
Thank you.
Okay, so you can see mesh is created, almost 6 lakhs 64,000 elements are being created, and within 1.88 minutes. So you can see how fast it works. So if you have used ANSYS meshing or even any other tool, so you will get an idea how exactly it is working. And this is how we are creating the mesh over here. You can see this is polyhedral elements that it has created on all the surfaces, okay. As you can see, on all the surfaces you will be having the polyhedral elements. On the wall surfaces, only this car model, that is we have named as a wall, and the bottom road surface, right? So there you will be able to see the inflation layer. So this is the inflation layer that you can see. Okay. uh, Here all the surfaces, so you can even add, check it out. Okay, so this inflation layer is also you will be able to see over here. Okay, and then this polyhedral elements, these are the hex core elements or hexahedral elements, and this is the mosaic mesh that you can see over that in this particular part. So this is the mosaic mesh that it creates, and that definitely gives you good mesh quality as well. Any like I have not given that good quality, but definitely you can even go for the more better mesh quality. I'm just since it is taking for it should take less time, so I have given the very coarser sizing, we can say. Okay, but you can definitely try it out, and it will give you the very good mesh as well. As you can see, you can take different cuts in the different sides, and you can check it out like this. Okay, so this is how you will be getting a very good mesh quality over here. And once this is done, now it is like a single window workflow from meshing till the final, that is result section, right? So once this is done, you just need to click on switch to solution mode. So it will be switching to the Fluent, where you can create go for the solution, or solve the problem and find out the results. Sorry. Okay, so it's switching to the solution mode now. So as you can see, now we are in a Fluent window where we need to apply the different solver settings, and we need to solve the model. Okay, I'll just try to give a simplest setting so that time taken will be less. We have, I think, 20 minutes more only, right? First of all, in left side you can see the outline view. Again, the GUI is almost similar. Here you have the console where you will be getting the different iteration, error messages, everything will be visible over here in this section. Okay, errors and warnings. So this is the graphics view. These are the different tools, or we can say tabs, that we have over here. Okay, so we just need to start, we need to follow this workflow again, outline view, to complete any simulation. Okay, and additional options are available in the various tabs over here. Again, starting with the general settings. So first of all, you can just scale the model. Here I just don't need to scale it, I'll just change the unit to If you want, you can just specify the scaling factors and you can scale it. I'll just change the unit and close it. Then perform the mesh check, and once it is done, I can view the report quality, and if quality is below acceptable range, you will be getting a warning over here. You need to improve the mesh. Then in display, you can view all the boundaries one by one. So this is the car model that we have, or that we have named. Then this is the inlet section, okay, which you can see in the blue color. Then this is the outlet in the green color. Okay, and then this is the road surface, that is wall, and this is the symmetry surface. Okay, in this black color. Okay, so these are the different boundaries that you can see. Then we'll solve it for steady state problem with very less velocity. So we'll go with the pressure based solver with the absolute velocity and steady state problem. Okay, enable the gravitational effect in the negative y direction. Now it supports the equation, so you just need to put minus g, sorry, minus g, so it will automatically, okay, it's not taking the okay, that for that you need to enable the expressions, then you have to give the minus g like this. Okay, otherwise you can give the constant like minus 9.81, okay, along the y direction. So in downward direction we have to leave. Okay, then go to the model. So in this case we'll be using the viscous k omega model in this turbulence models. Apart from that, as I told, various models are available based on the problems like multiphysics. We have heat exchanger species, radiation. Then for battery, we have battery models, lithium ion battery models. So different models are available. So for this, we for external aerodynamics, we just need to change it to k omega gecko. As I told, this gecko k omega model that we have, you can even go for the curvature correction, cornering flow correction, so that will tune the results for better accuracy. So just you can just enable this and just say okay. So you can see generalized k omega model is enabled. Material is default, that is air material, right? So if you wanted to add any new material, you just need to go to create edit, and in the fluent database you will be able to see the list of materials, fluid materials. So we have here 565 fluid materials available. Along with that, if you see in granta mds database is also added, where you have access to few solid materials over here. No fluid materials are available in the granta library, but various solids materials are available. Okay, we don't want to add any materials, so I'll just keep as it is. Sorry. Then go to the cell zone condition. This is our enclosure for which we need to assign this fluid, that is air. So just edit this. Okay. And here we can change the material. Now for this we have default material, so no need to make any changes. We can keep as it is. Just apply it and close. Operating conditions, apart from any room condition or standard conditions, if you wanted to change the operating conditions, you can just go to this operating conditions. Here you can see the pressure is 1 bar, that is 101325 pascal. Gravitational force that we have already enabled and value is given. If you wanted to change the operating density also, that also can be changed from here. Okay, I don't want to change anything, we'll keep as it is, so I'll just cancel this. And then boundary conditions. Now as you can see, first one is a car model. Okay, so car model that will act as a wall surface. As you can see in the types, it is wall. So just click on edit it. So let's we'll consider it mm, stationary wall with no slip condition. Okay, like how we test in a wind tunnel. So model will be steady and air will be flowing around it, right? So same way we are testing over here. So stationary wall with no slip condition, we can provide a roughness value as well on the surface if required. Okay, apply it and close. Next one is the inlet. So inlet should be velocity inlet. So as we are going to define the velocity at inlet one, so edit this, and here we will be giving the velocity value. Let's say for our problem we have 22 meter per second, right? So enable the velocity. Again you can for better accuracy and better uh, convergence results, so you can enable change these values as well. So you can give this turbulence specification method to intensity and length scale for the external problems, and if it is internal flow, then you have to define the intensity and hydraulic diameter. Here I will not make any changes, I'll just go as it is, click on apply and close it. Interior, that is the complete volume inside this particular domain, that will act as an interior only, so no need to make any changes, that's all. Then outlet, so it is a pressure outlet, you cannot define velocity at inlet and velocity at the outlet. So here you have to define pressure at the outlet. So initial gauge pressure that we need to give it as a 0. So make sure that initial gauge pressure is 0 over here. Just click on apply and close this. Then road, so the road surface that will also act as a wall, so you will be able to see the boundary layer formation on the road surface as well, right? So here you can see the type is wall. Again edit it, same condition that what we have given for the car, similar way we are going to apply it to the road surface also. Stationary wall with no slip condition. Okay, apply it and close it. Then symmetry, again for symmetry, you just need to make sure that type is given as a symmetry, so that there should not be any boundary layer formation on the symmetry surfaces. Okay, you cannot edit anything, just need to see the name. You just need to make sure the type is symmetry, that's all. We have given all the boundary conditions. In the reference values, you can say compute from inlet section, so that all the initial gas values or the reference values will be taken with respect to the inlet one. In the reference zone, you can select the complete volume, that is enclosure. Then in the methods, as I told, we have the different schemes: simple, simplex, piezo, coupled. So generally we go with the simple and coupled method for the general purpose applications, right? So here we'll go with the coupled, so that helps you to get a faster convergence, right? So select the coupled scheme again. As I told, high order term relaxation can be enabled for the more accuracy, so we can enable this. Again, in the solution controls, you can go for the under relaxation factor. If solution is not getting converged, then you need to change this parameter, so that can help you to get a convergence faster. Then report definition, here we can track the different force results like drag force, lift force, moment, momentum, so forces. So this can be tracked over here. So we'll track the drag and lift coefficient. So just go to the new force report, drag, and select the car model. So we have to find out the drag value and lift drag coefficient and lift coefficient around the car model, right? So select the car model. Here you can name this as a drag monitor. Okay, and then click on report file, report plot, print to console. So it will add to the report as well. So here you can see in the monitors, in the report section, currently nothing is there. When I'll add this drag monitor, so it will be added over here, as you can see. Okay, similarly we have to add the lift. So again, on our car body, report file, report plot, print to console, and lift monitor. Okay, given, say okay to this and close. Both are added. Then residual, if you want, you can go for higher accuracy as you require. I'll just keep it to 10 raised to minus power 3, so that we'll get a faster solution. You can generally be used to go with the 10 raised to minus power 6, 7, or until we are getting the stable results. That is also possible, okay, based on the time you have. Then go to the initialization. We can go for standard initialization and compute from the inlet. So you can see initial gas values will be taken with respect to the inlet. Click on initialize. So it will initialize the model, and once it is done, go to the run calculation, and you can give the number of iterations. Okay, so let's say I have given 1000 iterations, and click on calculate. Okay, so once the solution is completed, we'll be getting the drag and lift coefficients on the car model. Okay, as you can see, the iterations are starting. We'll be getting start getting the iterations value over here. Along with that, we'll get the residual plot, we'll get a drag monitor and lift coefficient monitors as well over here. Okay, okay, I have given 1000 iterations. We'll just solve it for the 100 iteration. Okay, so it should not take more time. Okay, you can see first iteration is completed. Like this is the residual, it will start plotting. Drag monitors and lift monitor also, it will start plotting over. This is the you can see number of cells are 6.6 means 0.6 million. You can say 0.66 million mesh we have. So it will be taking a little time to solve the problem. Okay, as you can see, residuals are started plotting, drag values are also started plotting, and lift values are also started plotting. Okay, once the solution will be completed, we can analyze the results. Okay, by the time it will get converged, or it will complete at least 70 80 iterations, we'll continue with the presentation. Okay, so then I will show you the results part. Apart from that, so there are various areas in the EV section where we can go for the research areas where we can have our research. So we can say in the electric machines, like we have the research area. Then for battery controllers, power electronics, system engineering, and functional safety, in all these we can do a simulation part, and ANSYS platforms are available for all these particular simulations. Then again, we say EV, so definitely in EV we have a lot of electronics designs. So electronic components are there. So for that thermal management is very important, and for that you can go for the thermal analysis of those particular components with the help of ANSYS. Then how we can learn the ANSYS? So we have ANSYS innovative courses, which is freely available for everyone to learn. So definitely you can learn from this. ANSYS innovative courses. Okay, so that will be helpful for you to understand. Okay, so to understand the various concepts, different theoretical concepts of different engineering aspects in the different subjects as well, it is possible. So these courses are developed by different industry professionals, keeping the different levels of the students in mind. So it is freely available. You just need to Google it for ANSYS innovative courses, and you can just enroll for the courses, and you can complete these courses. Apart from that, another tool we have, that is ANSYS Learning Hub. So it is a learning management system and a centralized knowledge portal that offers the rich level learning resources and continuous learning experience to the ANSYS customers across the portfolio. So here you'll be having a campus view like this, as you can see, where you have the buildings for each physics separately, and you can visit to your respective or concerned building where you wanted to learn. So here we have more than 900 plus recorded video modules for the self-paced learning. Again, every year there will be some collaborations with the different experts, so you can learn from the expert, where you can have a live Q&A session. You can use and get the material also from them to learn. Then we have the live classrooms. Every year used to be going on, but now since pandemic it is completely virtual classes are going on, but live classrooms are not possible. Okay, but yes, it is also there. Then we have the access to more than 240 plus courses, where we have more than 1000 plus workshops available. Again, whatever the different webinars worldwide will be there, that you can access to that concerning to different trends. So these webinars will be going on. So those are the different learning platforms. So again, ANSYS used to collaborate with the various institutes for the different fellowships, for the fellowship programs, or for already signed MOUs with the various institutes to develop the research labs in various institutes in either private or in the government institutes as well. And then we are the ARK Info Solutions Private Limited. We are the ANSYS channel partner and national distributor for the sales and technical support for in India and Shah countries for the ANSYS. Even we deal with the different brands over here. So thank you. That's all from my side. I'll just show you the results part. Just give me a moment. Yeah, still I think it's 30 iterations are completed, so we just need to wait for some more time to get the results. Yes, in the meantime, any questions, any doubts, if you have, we can discuss that.
Good evening, sir. I have
Good
a doubt.
evening. Yes.
Yeah, it's related to structural mechanics actually. Can I ask you?
Yes. Yes, please, sir.
Yeah, we are working on a contact model, highly nonlinear model, and
Okay.
we have a lot of convergence issues are that's related to biomechanics.
Okay. Okay.
So is it possible to, how good is the structural nonlinear solver of ANSYS, so that we can, continue, because we have a doubt on whether to continue or not. We have a doubt on that.
Sir, like what I can say to you is there might be certain issues that can be checked on that side, right? So maybe you are not able to get expected results, or even that is failing even to simulate the problem as well, right? So
Okay.
if in that cases, what you can do is you just you will be you need to contact to the ANSYS, and definitely they can suggest you the right path, and even they can even suggest you if it is not possible to perform that kind of simulation as well. So definitely, like if you you consult them, then that can be helpful for you, I can say.
Okay,
Alright.
so local ANSYS support I have to contact, right?
Yeah, definitely, because see, if you are not aware of the capability, if that can be done or not, so definitely it's doubtful. So you just first get that clear. Otherwise it is not good good to spend the time and then nothing will happen. But I can say definitely that should work because ANSYS nonlinear solution is also available. So you just need to check out how that can help you to get the solution. So you can talk to them.
Okay. Is it possible to contact you after this seminar? Email ID or something like that?
I will share you my mail ID in the chat, so you can just
drop. Is it okay? We'll be free enough to reply, right?
Sorry.
Because will be free, or if you send a mail, you will be able to reply to us now?
Yes, not today, but definitely tomorrow I'll try to reply, because again tomorrow I have another session over here itself, and I have already some engagement after this session as well. So definitely I'll reply. Or actually I'm from CFD background, so what I'll do is I'll share your query with the mechanical people so they can check out and reply.
Thank you, sir. Okay. Thank you. I will mail you.
Yeah.
Thank you.
Sure. Yeah. Thank you. Anything else?
Hello.
Yes, ma'am.
Sir, I have one question that for
Yes.
any IC engine vehicle and our electrical vehicle, both are having different thermal scenario. Means one
Yes.
will get different time and another will different time. So can I do that simulation using ANSYS?
Yes, you can do the simulation for battery thermal management that we are going to see tomorrow. So if you see the thermal analysis, so a lot of aspects are there. If you talk about EV, then you main component in EV that comes, that is a battery. So battery thermal management that can be easily done. So anyways, tomorrow we are going to see even the demo on that. And for the IC, like normal conventional vehicles, for that also a lot of parts are there for which you can do the thermal analysis. So that is also possible with ANSYS. If you can check out the thermal stresses, how the thermal stresses are going to generate due to that thermal heating, and also those things are also possible with the help of FSI or co-simulation, we call it as, right? So like 2A FSI between mechanical and CFD. So those things are also possible. So definitely you can try it out.
Okay, so camera means like suppose on any toll, vehicle toll, there two vehicles are entering. One is the electrical vehicle and another is the IC engine vehicle.
Okay.
And I want to check, normally now everywhere there is a green plate or that plate numbers is given. But if somebody intentionally do not want to show that, and if I have to check that how many vehicles on the road, which is actually vehicles and IC engine. So is there using a camera, can I interpret this ANSYS data? Any means, is it possible that way?
I think then it's comes like a AI part into this picture. Okay. Because the camera sensors that should have that capability to understand whether it is actually a EV or IC engine vehicle. So I'm little doubtful about it, whether we can do it. Because it's like you need to understand. Another way can be EV don't have anything in front or back, because so it's like you need to analyze it first. You need to do certain study to in what aspect we can differ them in a visualization also. And then definitely it should possible, because it's first understanding how we can differentiate both vehicles.
Okay, thank you, sir.
After that I think it will be possible. I'm just giving a rough idea. I'm as per my knowledge.
Okay, thank you, sir. Thank you.
Yeah. Yes, anything else?
Sir, is it possible to have a solar load modeling or
Sir, your voice is breaking.
solar panel?
Sir, your voice, we lost your voice.
Okay, sir. I'll type the question.
Please put your query in the chat box. I will read it out for you. Any other participant, if you have any other doubt, you can type in chat box. And I request all participants to try to ask questions which are directly related to the session, what we are going through. So it's better if we ask the expert the questions in his domain. So I request everyone. Yeah, there is one question. Is it possible to have solar load modeling with parabolic through collector?
Mm, with parabolic, what is parabolic exactly?
I guess
Like,
he's trying
so,
to say about parabolic shape of a solar collector plate.
okay, okay. I think it will be possible. The shape doesn't matter over there, right? Because we can model the different shapes, so that I don't think that should be an issue. You can do that modeling. Yes, it will be possible.
Yeah.
Anything else? Okay, then I think I'll just show you the results and then
Sure.
I'll just stop this. Okay, so I have completed 76 iterations. So it takes a little time. So we can see the still the results are not, we can say stable, but I'll just show you the results. So I'll just stop the solution over here. Okay, so this once we have stopped, you can see I have completed 78 the iteration, and now we wanted to find out the drag and lift coefficient. So you can go to this report definition again and select, let's say first we'll select the drag monitor. So just edit this, and you need to select the drag monitor and click on compute. So it will show you the result, how much drag we are getting on the car model. Here you can see CD, and then similarly for the lift monitor, uh, click on edit, and here you can again click on compute for the lift monitors. Sorry, I think I closed it. So here CL also you will be getting. So this way you will be getting the drag and lift coefficient results over here. Apart from that, you can check out the different results. So let's say you can go to this results part. The results is possible in the Fluent itself. Okay, so go to the contours, and if you wanted to plot a contour over here, so let's say go to new surface, and I'll just create a ISO surface over here, and let's make it of constant mesh along let's say z direction. Okay, at exactly middle, that is at 0 0. Okay, let's say create, and see this is the name of this contour. Okay, so just see, we'll just see the static pressure on this contour. Click on display, so you can see the pressure control over here. Okay, uh, and then similarly we can see the velocity contour as well, as you can see. Okay, and here you can see the maximum vortex shading over here in the back side over here, that you can observe. Similarly, if you wanted to check further results, you can go back to the workbench, and you can just add the CFD post to view the results. So I'll just make this as a up to accept interrupted solution up to date. Okay, and then go to the CFD post, where you can again find out the contours, streamlines, etc. Okay, but here in this particular simulation, main focus is on drag coefficient and lift coefficient, that we can very easily calculate as I shown. Okay, okay, so the model is importing over here. This is the CFD post. We have another tool that is called Insight. There also you can do the post processing, maybe for multiple physics as well together. So that is also possible over there. It's loading the model. Okay, it's imported. You can see this is the car model over here. Okay, and we can see the various contours around it. So you can just create a plane here also. Plane should be along xy at z is equal to 0. Okay, that is exactly at the center we have created a plane. Now on this plane we can observe the various results, like we can see the vectors on plane 1. So you can see the velocity vector. So this is how the uh, vectors are formed, or velocity vectors can be observed over. Okay, as you can see, and backflow in this particular region. Okay, also splitting, and you can see the direction is changing for the velocity of direction is changing for the air flow. Okay, then you can hide this. You can go for the contours. You can add the contours. You can check it on the plane 1, like pressure contour. You can see. So this is how pressure is varying inside this complete domain. Definitely we should have a little larger domain so that we can get more detailed results, but due to the time limitation I have taken a smaller domain over. Okay, and then instead of pressure you can even check the velocity as well. So this is the velocity contour. Now one thing you will observe, near the wall surfaces you will be able to see the velocity variation due to the boundary layer formation only on the wall surfaces. You can see the road or a car body. So you'll see the velocity variation around it, but not on the symmetry surface, because that is because we have given the symmetry boundary, and on the car body or on the road only we have given the wall surface. Okay, even you can observe this pressure on the car body as well. I'll hide the plane. Okay, that's not showing any variations. Okay, it's pressure. Yes, okay, so this is how the pressure is varying. On the front section, you can see you will be able to observe the maximum pressure. Okay, these are the different contours that we can observe. Then I'll hide the contours. You can create the streamlines. I'll directly create it on a volume. You can create on a plane as well. Okay, start from, you can select plane. I'll just select the complete enclosure. Let's say 400 streamlines and click on apply. Okay, so streamlines, you can see those are created, and you can see the animation for this. So go to the animation, select the streamlines. You can reduce the speed and create the animation. So you can see this is how flow is, or air is moving around this vehicle. Okay, you can even save this animation in the save movie option. So for the presentations or any other purpose, you can change the symbols of the animations. Like it's a ball, so in the options you have option to change it to any other part, like this here you can see. So these are options are all. Apart from that, if you want to put certain data, like generally in wind tunnel when you are doing a testing, so you put certain pressure probes or velocity probes at different locations where you wanted to find out the pressure variation after the body. Okay, so that can also be done over here. You can put a probe like this at any location. You just need to give the coordinate, so it will be automatically created at that location. You can get a velocity as well as the pressure, or in different results can be found out over. Okay, similar to that, if you wanted to create plots at different location, you can create a line. I'll just hide the streamlines and I'll give the exact coordinates. I'm not aware of the exact coordinates, but let's I'll just do the window selection, but you can give the exact coordinates over here. Okay. Let's say I'll start from this side. Okay, I'll enable the plane. And take the line command, line 1, and you can just I'm just giving randomly from the window, but you can easily create it by your own. Okay, like by giving the exact coordinates. I'll create one more line, this location. Okay, and on this we can plot the different results. Go to the chart. So here you can name the give the title, then series you can add line 1, again new series on line 2, and here along x, let's say you wanted to find out the velocity variation. Okay, like velocity profile, and along y, let's give the, sorry, here we name it as velocity, and along y, let's say vertical distance, that is y. So give it and just plot it, so you can see the velocity variation, as well as if you want you can just create a, I'll duplicate this, and here I'll just take it as a pressure variation. So because when you are going for the publication, even you can have this comparative data over there, and that you can put it. You can just take it to the Excel sheet also. Click on export, and you can export at given location with the help of Excel sheets. So I'll give it number, save it. So you can take it to the Excel sheet as well. So you can do use it for any further post-processing part as well, or for plotting different data, comparative data. So that is also possible, as you can see. Okay, so like this we can get various data, post-processing results, etc. Okay, I hope that is clear to you. I have taken I think almost 13 minutes extra from you. So
that was worth worth 13 minutes.
Okay.
It was a very nice session. I hope all participants agree with me. So if any other doubts are there, yeah. If any other doubts are there, we can spend few minutes, or otherwise we can close the session. Anybody is having any doubt?
Can we do such kind of analysis in Autodesk Fusion 360?
Sorry, sir, I don't know.
Okay.
Yeah, I cannot tell about another tool.
Okay.
Yeah, we can do, but we are having limited access to the limited tools in the Fusion 360.
Actually, those tools I can say not other tools are not that convenient for the various types of simulations and post-processing parts. Many things are there, different turbulence models. So that makes this tool better. I'm not praising, but definitely I have also been through various tools, so I can say this can be one of the better tool for the various simulations, not only for the external aerodynamics, but plenty of simulation can be done in a single tool. That is a beauty. Yeah, I have shared my mail ID in the chat box, so definitely if you have any queries or anything in the future also, you can get back to us. Okay.
Sure.
Any other
so, yeah. Anyone having any doubt? Okay, then I guess this is it. That was a very wonderful session by Mr. Kailas Jagtap. We have known him for a long time. He's a very expert in this field, and he has definitely shown us from very basic how to create a domain in space claim, how to correct the geometry, then making mosaic meshing, and then how to set up a boundary condition, problem statement in flow simulation, how to see the results, everything. That was very wonderful session, very informative. I guess most of us will be benefited by this session. I thank you very much, Mr. Kailas Jagtap, and we are looking forward to your next session tomorrow on battery
Definitely.
management system. Yeah.
Yeah,
So
definitely, sir. Thank you so much.
yeah. So thank you so much. Thank you so much, all the participants, for patiently listening to this session. I request everyone to fill up the feedback form pasted in the chat box. Thank you so much. Thank you. That's it for today. We'll conclude the session here. Have a nice day. Bye.
Okay. Thank you so much, everyone.
There are many requests regarding this recording of the session. Definitely, we'll provide the recording of session. Once all the videos are uploaded, we'll provide the recordings also. Thank you.